Hey everyone, my name is Daniel Moyer from Briggs Stratton Energy Solutions. Today I'm joined by Andrew from Sol-Ark. Hi, Andrew.
Hi, Daniel.
So, a couple of housekeeping items before we get started. This webinar is being recorded. Everybody who attends this is going to get a copy of the recording, a copy of the slide decks. Additionally, this course is approved by NABCEP, so I can offer continuing education credits for everybody who stays through the end. At the end of this presentation, my email is going to pop up. Please email me your full first and last name, spell it out for me so I get it right on your certificate, and I'll go ahead and email out those certificates. Lastly, the chat has been disabled, but Q&A is open and available. So please put in any questions or comments you have during the talk, and let's go ahead and get started. Andrew, welcome. Tell us a little bit about your history and what you do there at Sol-Ark.
Sure. So I'm Andrew Godin. I'm one of the field applications engineers at Sol-Ark. I've been with Sol-Ark actually closing in on 4 years now. I started with our tech support team and moved into sales, kind of trying to get ahead of any problems that anyone may have and support designs and everything pre-installation.
Yeah, thank you. I'm Daniel Moyer. I've been with Briggs Stratton for about 4 years now, 5 years, going on 5 years, and I'm one of the sales support trainers. So I support the sales team by offering trainings like the one you're here today as well. There's a lot of technical stuff in this, Andrew, so we're going to go quick. Just keep in mind that, again, everybody will have copies of this slide. Everybody will also have ability to review this as we send out the recording as well. So Andrew, one of the first things I think of is, Sol-Ark, you guys are based down in Texas. You're an American-based company, American-based tech support. Your warehouse, your factory is down in Texas. We're up in Milwaukee, a little bit colder up there, but still two American companies that have come together to support you, the installer, with our batteries, with the Sol-Ark. And there's been a lot of collaboration between our engineering teams, between our tech support teams, between our sales teams, so that when you come to install one of these systems, we're not going to point you in the inverter direction. Inverter company's not going to point you in the battery direction. We're really here to provide that energy independence from two U.S. companies. Anything to add to that, Andrew?
No, you covered it pretty well. I mean, Sol-Ark is, like you mentioned, was founded and is a U.S. based company, and one of our primary goals has been able to provide the energy and resilience to Americans. So we're uh, completely based here in Allen, Texas, and we do have some remote people, but mostly in sales and marketing roles across the United States.
Yeah, and I would say that we're not only providing energy independence, but we're also providing money back. A lot of places that don't necessarily have net metering policies, you can no longer just backfeed your solar to the grid. You have to be able to store that solar power, the excess solar power, in a reliable, long-lasting battery like our SimpliPHI 6.6 on the battery, and then discharge that energy to the home's loads at night. So yeah, not only that, and also, Andrew, there's a lot of new virtual power plants and demand response programs that are coming online as well, that we can
Yep.
show that financial savings, get some money back on these installs, and then the homeowner also gets cut a check for participating in these programs and for every dispatch that's also required as well. They differ around the
Yep.
country a little bit, and we could probably spend the whole hour talking about virtual power plants and the like. But today we're going to talk about some of the programming fundamentals on our SimpliPHI 6.6 and our Sol-Ark as well. Now, let's just quickly set the stage. I always like to kind of show this slide in a lot of my presentations, and it shows that Sol-Ark is kind of in the middle, right? The Sol-Ark, in a lot of ways, is kind of that hybrid inverter. Andrew, you guys took all the parts and pieces that we used to have: a separate charge controller, a separate inverter battery charger, a separate automatic generator start, a separate Mate 3S controller, right? You put it all into one box, that hybrid inverter right there. That's also where the transfer switch is, although we call it an MID. And what will happen is that if the Sol-Ark detects a loss of grid, it will disconnect from the grid within milliseconds. And a lot of times homeowners don't even notice that the loss of grid has occurred. I mean, maybe they might see the lights flicker for a millisecond. They like look out the window and see that the neighborhood is dark, or they look at their app and see that they're in an off-grid mode. I want to notice that there's no solar in this picture. There's no generator in this picture. And it's becoming more and more common where you can simply just have a battery with energy, juice in the battery. And then if the grid goes out, we'll be able to power the home's loads. Now, of course, we can always add solar to that. The solar will recharge the battery during the day while supporting the loads and get you through the night. If you've sized it correctly, you could essentially be an off-grid home, even though you're on grid. And Andrew, I've heard a lot more about that, the so-called grid defection, or people that are just so fed up with the grid that even though they're not living out in the woods and the mountains, they're here locally in town and yet choose to go off grid. And of course, you can bring in
Yep.
a generator as well. Go ahead, Andrew.
Yeah, absolutely. It's either people completely disconnecting from the grid that will be available to them, or uh, I like to use the case of my father a lot, where he could have paid for the power company to, run a line out to his property, but just the cost of doing that would have cost the same as having a Sol-Ark system and some batteries and a backup generator. So, it made a lot more sense for him to just do a completely off-grid system and not have a electricity bill.
Yeah, and that last point you made, Andrew, is great. He doesn't have an electrical bill, right? So he's
Right.
not paying 100, 200, $300 a month for the indefinite future. He's able to produce his own energy, store it, and use it himself. So great point. One thing I'm excited to show everybody is historically the SimpliPHI 6.6 battery had a control. It still has a battery controller at the top. It's where the communication cables go. It's where the power conductors go down to the inverter. And that always had the 2-inch knockout on the right-hand side of the inverter, of the controller. So that was easy, right? If you had the inverter on the right, battery on the left, you could easily pipe it down. We've now launched a dual-sided controller. So now you can come out either the right or the left-hand side and feed it down into a 15K, a 12K, 18K, whatever the solar converter might be. In the past, I've seen, installers have to pipe conduit out the right-hand side, up and over and down into the Sol-Ark. This makes it, I think, one of the biggest benefits. It makes it much cleaner look. Also, it reduces the amount of labor and conduit that you need to use to make this system work here. So I think it's a great small improvement. And I know Sol-Ark does this. We do this. We listen to installer feedback and make the appropriate changes and improvements incrementally as our products develop and continue to grow. So I think this is really cool scenario here. Although you actually can now also daisy chain two batteries together, just up to two batteries, so that you're not having to pipe the inverters separately over. You can run one stack into another, out of that stack closest to the inverter, come out and feed up into the Sol-Ark. So again, nice improvement. We're still keeping the single-sided controller. The dual-sided controller is now an optional piece. So Andrew, these are the Sol-Ark lineups. Now, there's a couple of your high voltage 30K and 60K
Mhm.
inverters I left out, and we no longer see the 8K Sol-Ark on the list. So these are kind of the inverters that are able to partner with our SimpliPHI 6.6 battery. And I'm looking kind of, Andrew, on the right-hand side, the Sol-Ark 18K. I'm really excited, right? And a lot of older installs, we might have had to parallel two or more inverters to create enough power to get a home, a larger home running. Now you got an 18K, 18,000 watts from batteries, two loads in one box. And it's not much bigger than the 15K, right? Tell us a little bit more about that
Yeah.
18K and why you're excited about it.
Yeah. So one of the biggest things with the 18K is we actually have a 50% jump in power when we're on battery only. So if you notice with the 15K, even though it can output 15 kilowatts AC, uh, when PV is available, the 18K inverter is going to be able to provide 18 kilowatts of output, uh, whether or not you have PV available. So it's actually a huge jump in power from, our previous flagship with the 15K.
Yeah, and it can surge to 36,000 watts. All of these inverters can surge to start some of those motor loads as well. Really excited. I mean, I don't even know where you're going to put 28,800 watts of solar out there somewhere, let alone being able to bring in AC coupled solar as well. Generator ports now 120 amps continuous, so you can bring in close to 30,000 watt generator on that 18K. Now, on the left-hand side, let's go to the other side, the Sol-Ark 12K. Now, you guys just announced the launch of a new and improved Sol-Ark 12K, and I like that. You didn't come out with a brand new inverter. You took something that works, something that people know, and you just made it better. You didn't, re-release and reinvent the wheel. So these are the specs for the older 12K. One thing I really like about your new 12K is that it's going to have now 100 amp pass through, not the 62 amp pass through. I like that, right? Everybody keeps going bigger and bigger. You guys did with the 18K, but now there's an opportunity to do a smaller system. Not everybody needs a 200 amp pass through. Not everybody needs to back up a whole home. My home still has a 100 amp service. There's an opportunity to do that as well. What do you like about the new 12K, and when is it going to be ready for market and available?
So it should be available in July. We sent off the 12K for UL testing and all of that. So, uh, you know, as far as I know, we're just waiting for the finalized test to come in, and I think we've already received the draft. So I believe it's going to be on schedule for a July, June or July launch, probably July. But some of the one of the biggest differences in it is it's going to be a 12K inverter. I think the current 12K, as a lot of people would probably point out, is its output is 9 kilowatts, and that's whether or not you have PV and battery combined. Its max output's 9 kilowatts, whereas the new 12K, we're calling it the 12K limitless, to kind of go in line with the 15 and 18 naming convention. It'll be able to output 12 kilowatts with PV. When it is on battery power only, it will be 10 kilowatts. But for the size of the inverter, because it is substantially smaller physically as well,
Yep.
it's actually going to be pretty powerful. And just like you mentioned, Daniel, it's going to have 100 amps of pass through. We've basically taken the MPPTs from the 15K and put it in this new unit as well. So it's going to have a 26 amp limit with per MPPT, and there's going to be 3 MPPTs still with 2 inputs each. So really going to be able to stack the PV on this unit as well, and take advantage of some of those newer modules where the existing 12K is limited to 20 amps per MPPT. So I really started getting limited, and it's starting to show its age a little bit. So we're just kind of giving it a refresh, and not um, completely reinventing the wheel, but
Yeah.
giving it a upgrade for sure.
So, Andrew, I'd love to have you back with us when that does launch, and we'll go into a deep dive on that new 12K. Really excited to look at that. Let's quickly. So, again, the topic we're about to get into it is programming a Sol-Ark, but it's really important that we take a quick look on the inside. What we're looking at is the inside of a Sol-Ark 15K. On the right-hand side, we have grid input. We can take 200 amps in on grid, 200 amps right back out on load. If grid goes down, the grid input will disconnect us from grid. We have a third port, a gen port, which stands for general, not generator. And that can be used for a generator, smart load, or AC coupled solar. And we're going to talk today about how to program a Sol-Ark for each of those scenarios. You got a load disconnect. Down at the bottom right, we have our neutral bar, our ground bar. We have our parallel comms. That's where if we have multiple inverters, we would allow the inverters to talk to each other through there. Battery CAN bus is where we're going to talk to our SimpliPHI 6.6. We got the accessory pinouts. We'll go over those here in a deeper dive in a second. Solar MPPT charge controllers. You got 3 of them down along the bottom. That's the little orange tabs there. And then on the left is we have dual battery inputs. Now, Andrew, I really like this, is that there's 2 positives, 2 negatives. That allows us, if we have 2 stacks of SimpliPHI 6.6 batteries, we can bring those into a Sol-Ark without the need for an external bus bar. Again, making this install quicker, less expensive, less one box to hang on the wall. And you got the battery breakers there as well. So let's take a little bit deeper dive look at that accessory pinouts. So Andrew, CTs, which can measure the amount of current flowing through a wire, and then it knows the voltage, so it can tell us how many watts or kilowatts are flowing through a wire. Those are already installed on the ports. But you offer the ability for external CTs. And I read in your manuals, you guys always suggest to install external CTs. I can also see a scenario where if you have a main panel and you're not backing up the whole home, you want to be able to measure the amount of power being consumed in non-backed up loads. So maybe we are able to do time of use where we can discharge to the main non-backed up loads when grid is up, so that we're not drawing from grid. So that's one scenario, right? And we can use some of your PCS controls to do that. So we're sending power back to the main non-backed up load center, but not so much that it goes back onto grid. We also, see that we have more accuracy. So after I just kind of summarize that, do you recommend installing CTs even though you have them built in? What are your thoughts?
I'd say it depends on the installation. If someone's using a 15K or 18K for whole home backup, so essentially the inverter would be installed between the meter and the main panel, and it's a single inverter, I'd say they're not necessary since we will have the internal measurements through the inverter. But if you're installing multiple inverters in parallel, they're going to be good to use because it'll provide a single point of reference for all of the inverters there from the grid. Or the other scenario, like you mentioned, if we're not doing a whole home backup and there's a essential load panel and there's a main panel upstream from the Sol-Ark, or let's say there's an installation on a 400 amp service and there's only one of those 200 amp panels being backed up, we can still meter the entire service and backfeed battery and solar and measure the loads of the entire home.
Pin 7 and 8 are the 2-wire signal to start. That's going to be able to start up our Briggs Stratton generator when grid is down and when the batteries start to get low. And we're going to talk about how to program that as well. E-stop, right? A lot of codes and jurisdictions are requiring emergency stop buttons. You hit this right button, the mushroom button that you're going to install in a readily accessible location. It's going to stop all power coming in and out of the Sol-Ark. It's also going to stop powering the transmitter for the rapid shutdown power supply inside of the Sol-Ark, so that any Tigos or AP Smart System rapid shutdown devices will also shut down the solar as well. And that's where we're down there on pins 15 and 16. Now, Andrew, some of the criticism, and not criticism, but just feedback, is that, that transmitter, the power supply on that pinout is 100 milliamps. Now, I know that Tigo, if you look carefully on some of the Tigo transmitters, right, we got to power a transmitter, which then sends a signal along the PV cables to the rapid shutdown devices, the TS4Fs up on the roof. That transmitter sometimes requires more than 100 milliamps. I've heard that the new Sol-Ark 12K is going to be more powerful, so we no longer have to put in that breaker with the power supply. Can you shed any light on that?
That's correct. I don't know exactly what the power rating is on that yet. I don't have all the specs of the new 12K, other than some of the main ones I mentioned previously. But not only that, we have kind of released some of the roadmap products for the year for our residential lineup, and we should hopefully have a product of our own to not even need anything like this by the end of the year.
Andrew, I'm going to welcome you back when that product releases so we can do a webinar on that as well. Out of that pins, out of the Sol-Ark, if you are running it into a Briggs Stratton generator, it's going to be pins 4 and 5 inside our generator to send that 2-wire signal to start as well. Now, earlier I talked to Andrew about your dual battery input. So if we have 2 stacks, like we see kind of in the center of our screen, that's easy, right? One red, one black coming off of both those battery stacks, and we feed it into all 4 of those battery inputs. But if we have a single stack, like I see on the left there, I want to still take the power cables coming out of that battery and feed it into all 4 of our battery inputs. Because if you notice up above that you have 2 breakers there. So if I were only feed one red, one black, I would be limited to what? 200 amps DC. So I want to be able to bring power into all 4. So if I got a single stack, what we've done at Briggs & Stratton with that SimpliPHI battery is actually have a raised terminal on the battery lug so you can double lug. You have 2 reds, 2 blacks coming off that single stack and feed 2 reds, 2 blacks like you see there into our input. Now, Andrew, I've seen in some of the other installs that there's these bus bars. You can see them down in the bottom right-hand corner where we call them fork adapters, I've heard them called, where you kind of combine the inputs before you head into the dual battery inputs. And that would mean I only need one red, one black, thicker gauge wire, right? Because I'm handling all of the current coming off the battery. What's best practice? Should we do the double lug dual conductors, or should we be thinking about these fork adapters?
I'd always recommend 2 parallel sets of wire, just like is shown in the picture there. One thing with those Y bus bars that I've seen photo evidence of either the conductors heating up because they unfortunately did not size their conductors large enough. Not all 4-aught wire, which is typically what would be used with those Y bus bars, will be rated for a continuous 275 amps for the 15K, for example. So the conductors can get too hot. So I've seen melting around those terminals, or the weak point may be where they're lugged on. So I would definitely say proceed with caution. Also, since we have more, we've changed some components as we've gone to more domestically sourced parts for our inverters. The physical properties of the terminals have changed a little bit as well. So some of those bus bars may not even fit properly and have clearance on those terminals also. So if those terminals are touching, some of the plastic there, obviously that's starting to get hot and that's going to cause you problems as well. So it's always going to be safest to use two parallel sets of wire. That's how it was really designed. So
Yeah. And I also, Andrew, as I'm looking at this picture, Briggs & Stratton, SimpliPHI Power, and Sol-Ark go way back, so far back that the pictures of the Sol-Arks that I have on the screen don't really reflect the modern versions of Sol-Ark. I mean, our history goes back to the SimpliPHI days as well, your founding. So it's really exciting to see the history of us there. Thank you for the comments on the bus bars. Another update, right? And this has been a while. You guys recently update this. What I'm showing is my Sol-Ark. This is the web app, but you guys recently updated your mobile app. Can you tell us a little bit about that?
yeah, so the new mobile app that we just launched is primarily homeowner focused. So a much simpler interface that's easier to read, especially at first glance. Most homeowners, they just kind of want to know how their system's performing without really jumping into the details of each thing. Of course, I'd say the legacy app is still available, and if they want more details, they can still use that. or log on via the web interface. Of course, have a much larger screen to look at the graphs a little bit better. We will be overhauling the web interface in the future also. And then we're also going to be releasing a installer focused app that will add a guided commissioning process with a new connectivity dongle that will be launching, should be next month as well. So lots of improvements coming on the software front from Sol-Ark as well.
Yeah, that's exciting. Again, we'll have to have you come back. So knowing all that, as we continue through this webinar, the way we're going to kind of show programming is going to be through the screen on the Sol-Ark, not through the apps. Your apps change, so I like that you guys kept a screen. A lot of people are getting rid of screens, but everything you need to do can be done through that screen. And that's exactly what we're going to kind of show here as we get going. Every system does need that controller up top. You can have up to 3 batteries. The SimpliPHI 6.6 or 6.6 kilowatt hours each. You stack them together, you get 20 kilowatt hours. We have a base down at the bottom, either floor or wall mounted, universal. You're going to have the letter D is going to be your Sol-Ark inverter. Then we also have an optional energy track app. That's our app that allows us to get a little more granular detail on the batteries. And it also allows tech support to come along and push firmware updates as well. It's optional. 15-year warranty on our batteries, unlimited cycles, 100% depth of discharge with no throughput as well. Now, Andrew, we were looking at the power output of those Sol-Arks, right? 18K can do 18,000 watts from batteries to loads. Your 15K can do 12,000 watts from batteries to loads. That new 12K you're coming out is 10,000 watts from batteries to loads. What I'm showing on the screen here is you can have a single, a double, or a triple stack of our batteries, but I want to call out the continuous power output of the battery stacks, right? So if we got this 3 stack right here, that's 14,000 watts continuous output. So that's perfect for a Sol-Ark 15K, right? You're only asking from 12 from the battery. The battery can do 14. The bottleneck is not in the battery. But if we're going to start talking about that 18K, right, we're going to need to think about that a 3 stack is only 14, right? So we're going to be throttling back on the Sol-Ark side the ability to power load. So if you're going to do an 18K, you're going to need at least 2 stacks of batteries or 2 controllers. So you could do 2 stacks of 3, a stack of 3, 2, whatever the case may be. But I would also think that if you're doing an 18K, you're probably going to want more than 20 kilowatt hours of storage anyway. On the right, we can go up to 6 stacks in a system for 120 kilowatt hours and 84 kilowatts of continuous power as well. There's the screen. This is a training wall that my boss and I built here. We got our battery on the left there, Sol-Ark 15K. We got our critical loads panel with that red light showing grid. Down on the bottom right is backed up loads with that green light bulb there. So let's get into some programming. So, after you do all the wiring, essentially, keep in mind that, and I'm looking down at the bottom right-hand corner, that Andrew, you guys got this box. It's called BMS lithium bat, right? And by default, that's not checked. So what you got to do is do all your wiring. Don't turn the battery on, but turn the inverter on using grid, get into the settings, and then check that BMS lithium bat. Also, keep in mind, as we're talking through programming, think of, you got to hit the button, then also hit OK. The OK I like to think of as the save button on a Sol-Ark. So we can go ahead and do that. That will enable the battery communications between the inverter and the battery. If you have an off-grid system, it's a little similar, right? If you off-grid, you don't have grid to power on the inverter. Leave the communications unplugged. Use the battery to turn on the inverter. Do that checkpoint, and then you can turn everything off and reconnect the cables as well. Anything to add, Andrew?
No, I think you nailed it. And one thing I always would recommend after doing any of this, especially for the off-grid systems, is just powering the inverter on by itself, um, from the battery. Wait until you get a normal light, and then start adding other power sources and the load. So add the PV after you get a normal light, and then turn on the load. And then if you have a generator, you can do a generator test, make sure it'll connect and all of
Yeah.
that.
Yeah, we're going to show how to do that. The Gen Force button come up here in a second. Yeah, that's a good point. When you power up a Sol-Ark, the screen comes alive, but the inverter is actually not on. You still have to hold the power button. And it'll say power off, so you know what you're looking at. Okay, great. We've got battery communications between the inverter and battery set up. So now what we can do is we can turn on our SimpliPHI 6.6 battery. There's a power button on the controller at the top of the battery stack. You press and hold that button. The green light will come on, and you'll see green lights pop up on the batteries. Now, and know this, that battery breaker that we showed earlier on the inside of the Sol-Ark is still off. So we got our battery on, and we're going to flip on that battery breaker inside the Sol-Ark. And with these transformerless inverters, Andrew, there's a lot of capacitors in your inverters. So there's going to be a large inrush of current from the battery into the Sol-Ark to charge up those capacitors. That may trigger the battery management system to detect an overload. And so it's going to kind of turn off the battery, but the battery will restart itself after, I think, about 60 seconds or so. And then you'll be good to go. Just know that may happen, may not. And when it's reconnected, those capacitors will still have some charge left in them. So it'll be able to come back alive as well.
Yep.
And when you do those connections, you're going to see a lot of the battery settings are automatically going to be populated in the Sol-Ark. And a lot of them become grayed out when the communications have been established. And that's because the battery is telling the Sol-Ark what those settings should be dynamically as well. What you can see here is so we're on the, so let me go back to screen just so we can know, is that on the screen of the Sol-Ark, right? We can kind of talk through these, but they're pretty self-evident. There's a little gear icon up here on the right-hand side. That's what we're going to hit. When you hit the gear icon, you're going to be brought to this menu here. So we're basic setup. That's like setting the clock and stuff like that. We've now gone into battery setup. Battery setup is going to look like this screen. And the first one we talked about is the BAT tab. And that's where we activated the BMS lithium bat. Now, we're going to continue down here, and we're also going to stay on the BAT tab. But now we're going to also look over here is setting the battery capacity, which should be automatically populated, but also the max amp charge and discharge here. Now you can look, I got a kind of a chart over here on the right-hand side. And let's just use the Sol-Ark 15K, for example, with a stack of three 6.6 modules. You can see on the discharge is that it's 273 amps. Now, Andrew, you said it earlier, you guys, the Sol-Ark 15K can do 275 amps. So you're going to come in here and put in max discharge 273. Now, if I had 6 stacks, right, I could do 546 amps, but the Sol-Ark 15K by itself won't let you go higher than 275. When we come up here to the charge tab, again, you can see that we've had 3 batteries, and we're going to do 195 amps. This is DC. And Andrew, I'd love if you put DC there, DC amps. This is not AC amps. And that's the ability for us to charge. Now, Andrew, I usually leave the discharge as high as I can get it. Sometimes I do dial back the charge a little bit, especially if I'm not trying to pop a breaker because I'm coming off of a critical loads panel, or I'm not backing up the entire home as well. Anything to add to this?
No, I like the recommendation for a slightly lower charge rate. It it can definitely improve the life of the batteries, over several years, especially if you have a larger array. For people that have a smaller PV system, then they might not be hitting those charge rates anyway. But
Yep.
it's still good to, I'd say, to have that be a lower value. But definitely, if you have the battery capacity available, uh, allow your inverter to hit that maximum discharge rate.
Yeah, I mean, and that discharge rate's like an hour and 15 minutes you would drain the battery. Most people don't drain a battery in an hour and 15 minutes, but I'm sure you could tell us some more stories about that comment there. So keep in mind those settings that we just talked about are global settings. Now what we've done is we're still in the bat setup. We've gone from the bat tab to the charge tab. And what we're seeing here are two kind of columns right here. We're seeing the gen charge. If we select that and we got 60 amps, that's the amount of power that will come from the gen port to charge up batteries. And it would start at 40%. So right if we want the generator to come on when the batteries are starting to get low, when the grid's down, once the batteries reach 40%, if you have it set up like you see there, the generator would start when the battery's at 40%, and we would charge it at 60 amps DC. While the generator is running, all of the loads would also be satisfied as well. The grid charge, if grid is there, I have it set to charge at 100 amps, and that the grid would start to recharge the battery at 50% here. All of that float, absorb, equalizes all auto-populated by the battery. You can program in some default values before you connect closed loop communications so that if ever closed loop communications is lost, those values will revert back to the defaults that you put in there. But you'd only be able to do that if there's no closed loop comms. Just understand that those will all be auto-populated as well.
Yep.
Going over to the discharge tab, we're still in the bat setup tab, and discharge, right? I see three values there, right, Andrew? I see low bat, which would kind of occur first. That's when the batteries are getting low. There's no solar, there's no grid, there's no generator. When the batteries get to 20%, you're going to get an alarm, right? The inverters are going to start beeping at you. You might get an alarm on your app too. If they don't do anything, they don't shut off loads, the homeowner, at 10%, the loads to the house will get shut off. That's the shut off value. The inverter is going to stay on, and we want some juice left in the battery to keep the inverter on, so that if solar does come back out, if the grid comes back, well, the grid would turn the inverter on anyway, but you want to leave a little bit in to account for the parasitic draw of the inverter. All right, grid's back. Solar's producing. The loads aren't going to turn right back on. We want to let that battery get a good charge, maybe up to 50%, which is what I have here, before we restart supporting the loads. Andrew, what do you think about the values I have here, and do you have any suggestions?
I'd say the values can vary depending on how large the battery is as well. I'd say with a smaller battery, 10% might be a little low, but with a larger battery, you would have more reserve to keep the inverter on in an idle state. So it I'd say it depends. I mean, I know it's a little ambiguous, but I'd say smaller battery, I'd put the shutdown at maybe 15 or 20%, and
Yeah.
then low battery, 10% above that. Restart 40% or higher.
Okay. Yeah, and that's a great point. So we don't want to do a black start, right? Which is where the battery is completely drained. It turned itself off to protect itself, and the inverter is totally dead. Grid came back, the inverter would restart and start working, but we want to be able to get solar on the next day as well. And, in a parasitic draw on a Sol-Ark might be 50 or 100 watts, right? That could be more, 1.2 kilowatt hours, or what is that? Almost 2 kilowatt hours a day. Or something like that, if you got a 100-watt parasitic draw. So, and I think that parasitic draw can vary, but that's a good point that if I got a bigger battery, I can set that a little bit lower. Oh, okay, so we're back onto the main screen. One thing I wanted to always let people know is click the lithium bat info. What that's going to show us is going to pull up the screens that I show you on the right-hand side. The first thing I want to look at quickly is the nominal capacity, right? So if each of our SimpliPHI 6.6 batteries is 130 amp hours, whatever 130 times 3, right, is what we want to see as our, it should be 260, right? That's the capacity here. So 398 divided by 130 is, you know, a three stack. So I think I might have got my math wrong there. But what I'm trying to say here is look on the spec sheet of your batteries, understand how many amp hours each battery is in the stack, make sure it corresponds there. If you got like a single large battery, right, if you're not seeing anything in the nominal capacity, that means that there's a closed loop communication gap there. Additionally, the battery can actually tell the inverter to reduce its charge rate, and you'll see that represented here, right? So on the bottom right-hand side, discharge rate's 270, charge rate's 195, but the charge up on the top screen 65. That will change dynamically as well. Well, any questions, Andrew? I see one popped up.
Yeah, it's kind of a two-part, one for you and one for me.
Let's hear it if you want to read it.
Yeah, so I'll click answer live here. Does Briggs & Stratton plan on having batteries larger than 6.6 kilowatt hours, considering in Texas the average usage is 36 to 40 kilowatt hours per day?
Yeah, absolutely. There's always stuff on the horizon. You know, my house uses 20 kilowatt hours. So what we like about the modular batteries, the SimpliPHI 6.6, is that they don't weigh 350 pounds. That you can, two people or even one person can install a battery by themselves. And we have the ability to go up to 6 battery stacks. So we can get larger systems but also be able to have variable sizes as well. So yeah, the future is always open. You know, like you, Andrew, Sol-Ark is always developing. So are we as well. But I would say, you know, that scenario, you might get 3 or 4 stacks. And I got some pictures of some of those larger installs. What's on the deck for you?
The second part was on the 12 kilowatt inverter, does it support a wired remote second display? There's a display on the unit, but if the project puts the inverter inside something, can you put a wired second display that duplicates the original and mount it accessible to the user outside the box the unit is in? So currently, no, at least not something officially supported by Sol-Ark or produced by us. There is a third-party solution called Solar Assistant where you could probably do that using a Raspberry Pi system. It's relatively inexpensive. I've heard of people doing something like that. I mean, also with the Sol-Ark apps, there might be something that could be easily set up using just the remote monitoring that we already have.
Yeah, exactly. Use the app. But again, that's a great question. Maybe get a Trimetrics battery meter and hook up one of those old ones. You know, Andrew, just doing a time check. We have about a little over 15 minutes. So if you want to answer some of the questions on the chat, feel free. And then any good ones, save it for the end and we'll take a look at it.
Okay.
Remember that gen port? That gen port can do several things. It can be a load output. So we're looking, these are right out of your wiring diagrams, Andrew, in the back of your manual. So we got grid, we got our meter socket, and we're coming down to a disconnect. We got grid flowing in, grid out the load port flowing right back out. We're passing through 200 amps, and we can support the backed up, the entire home backed up right here. Grid will isolate us from grid if grid loss is detected. We can use that gen port as a smart load output. And what that kind of means is that grid is gone and not everything in the home in that bottom right-hand panel is backed up. Everything in this panel is also backed up. And this doesn't have to be a sub panel, it can also be just like an EV charger, for example. As the batteries start to drain and get to a certain point, we can turn off this load panel or this car charger or whatever it may be at a certain battery percentage. That way, we turn off what are kind of maybe the luxury loads as well, while reserving battery power to keep the main home loads open. And Andrew, I always hear it as that, like that we're going to turn off that load center when the batteries get low. That I like that. That makes sense. But I also like to think that say we're off grid, grid's down. The we wake up in the morning, the batteries are kind of low. They're we're kind of coasting in the morning. The sun comes up by noon or 1 p.m. The batteries are completely charged. The solar is powering all of the loads in the house. Well, if there's still excess solar, it has nowhere to go. The charge controllers are going to throttle that. So you're wasting solar. Solar produces power when it has a place to go. So I like to think of the smart load port as turning on when the batteries are full to use that extra solar rather than turning off to save the battery.
Absolutely. It,
When to
People
do
can get
that, yeah.
creative with all kinds of different loads, heat, water, whatever.
Um, so we're still in that bat setup tab. We remember we've gone through bat, charge, discharge tab. Now we're on the smart load tab here. We're gonna click this box saying use gen input as a load output. On grid always on means that smart load sub panel will always be on if grid is on. I've actually heard some scenarios where you don't want to check that, Andrew. I don't know if we have time to get into that. Essentially, they're trying to always use solar as much as possible. We'll have to save that conversation for another day. But look down on the left here. Smart load off battery. That means when the batteries are below 80%, that smart load port is off. Smart load on bat, that means when the batteries are 90% or more full, they're getting full, we'll turn that smart load port on, or the gen port essentially. And we have a little differential in there, right? Because we don't want them coming off and on as we flip and flop there as well. AC coupled solar. This is common, right? We come out to a house that already has existing solar. We don't want to already microinverters, maybe a string inverter. We want to bring it in. So instead of that load port or that sub panel on the smart load port, now we're bringing in AC coupled inverters. We're sending power into that gen port. We've seen this a lot. Here's some real pictures, Andrew. A couple of SolarEdge inverters feeding into that gen port on the Sol-Ark, and we got two of our SimpliPHI 6.6 batteries there as well. And you can still add DC coupled solar as well into those charge controllers. So we're still in that smart load tab, even though we're not doing a smart load, Andrew. We're still on that tab. We've now, instead of using gen input as load output, we've checked for AC coupled input into gen. We need to make sure that grid cell is enabled. And notice these numbers got flip-flopped, right? So, the long story short is AC coupled solar, if it's producing AC, it has to have somewhere to go. And the Sol-Ark, when it's grid forming, can use frequency adjusting to curtail the production of AC microinverters or a string inverter. But we want to turn that AC coupled solar off before the batteries get full. So notice in the last one, right, we had it flip-flop. So now we're going to turn the smart load battery off when the batteries get to 90%. So we don't want the AC coupled solar producing when the batteries are getting full. But the smart load on is anything under 80%. So we want the AC coupled solar producing when the batteries are kind of low. Andrew, what do you think about those values? Do you think those are appropriate?
I'd say that's a pretty good place to start. Once again, this can, vary depending on your battery size. So if you have a larger battery, you could potentially go to 95% and 85% because you have more capacity before there may be a concern of, you know, potentially overcharging your battery. But typically I would say 90% is a safe place to set it.
Yeah.
And
And
then
maybe also a function of the size of the AC coupled solar array as well.
exactly. Yeah. And then for grid tied systems, it's always going to be able to charge the battery up to 100% as long as the grid's available.
Yep. Yeah, that's a good point. This is only off grid, right? If it's that's
Right.
why, grid cell, we have that enabled. If grid is there, it's grid following, and the AC coupled solar will be able to produce, charge it up, extra it can send back.
Yep.
So we can bring a generator in. Briggs & Stratton has a line of air-cooled generators from 13 up to 26 kilowatts. And we also have commercial generators as well. So again, we're looking at the same diagram here. That gen port can also be used to bring a generator in as well. I think, and there's a great picture on the bottom left, Andrew, of what these larger systems can do here as well. This top right picture is an off-grid home. Okay, there's a little bit of programming in the Briggs & Stratton generator in order to enable the two-wire signal to start. So, Andrew, I always thought that a generator always feeds power to a home, but actually you're always feeding power to a generator all the time. You have to feed power to a generator to keep its starting battery charged, to keep any cold weather accessories, keeping the engine warm and the battery warm, but also you're sending power to a generator so the generator knows when grid is there or not there. And if it sees that grid is not there, it's going to start itself up. But if you backed up the whole home and the generator is going to see grid, even when you lose grid, because you're now using energy from a battery and a solar to power the home, you got to get into the controller on the generator and tell it that disable mains monitoring, or say that if you still see the presence of grid, which it isn't grid, right? It's the grid being formed by the Sol-Ark, but you see the presence of two-wire signal to start, go ahead and start up. So that's what I'm talking about on the left. On the right, we kind of already talked through this a little bit about what percent do we want the generator to start. And then also the screen here, again, we're in the bat setup, is that we need to make sure the gen limit power, that we don't overload the generator. So if we talked earlier that Sol-Ark 18K can take in, 30,000 watts of generator power. But really, if we only hook a 13 up to it, we only want 13 there as well. This is what the screen will look like when generator power is coming in. And it is also possible to bring a generator in on the grid port right here. So this is nice because then it frees up that gen port for smart load ports as well. So when we have a generator, we still have a transfer switch here. So grid will come in. Normally, this transfer switch will be in a vertical position. And if grid is lost, it will stay in the vertical position. When the batteries start to get low, the generator will send a two-wire signal to start up the generator, and then be able to power through the grid port right here as well. The generator is on the utility port. You need to tell it that. Again, we're in the grid parameter section. We already looked through really quickly on the controller here. And then we also have the battery charge right here as well. Andrew, you want to talk a little bit through, and we don't have to walk us all through it here, but talk us a little about through grid cell, limited power to home, time of use settings, and how you also have a time of use thing that's able to do different days of the week and different seasons as well.
Oh, yeah. So this could be probably an entire webinar in itself. Time of use can um, be a little much to wrap your head around until you've used it a few times. I'll start from the top though. So grid cell is exactly as it sounds. It's how much excess PV production that you would export to the grid. So with our PCS certification, we can reduce that or turn it off to meet requirements from the utility. Limited power to home is going to instruct the Sol-Ark to utilize the external CTs to meter upstream loads to be able to, meter what's going on external to Sol-Ark, and also be able to measure how much excess PV is or how much PV would be going to that other panel without pushing it to the grid, and we can also use it for discharging the battery to cover loads in those other panels as well.
Yeah, I think for time of use, considering we have our time of use right now is a little limited. We'll save that. I know you guys have some great videos that talk everybody through this. Essentially, you can get in there, and if your homeowner pays more money for certain times of the day, you can program the Sol-Ark to charge when power is cheap, discharge power when power is expensive. And sometimes these utilities change throughout the days of the week and throughout the seasons as well. So I think, Andrew, what I'll do is maybe look for that video and put it in the email that goes out to everybody as well. Anything else to add? I know I cut you off. Sorry there.
No worries. Yeah, just like you said, it's basically a schedule to discharge the batteries based on 6 different time slots in a 24-hour period.
You can turn off the beep if you want. If you got that homeowner that likes to get in there and play with stuff and mess with stuff, you can actually lock out this screen as well. And you can also do a factory reset as well. Andrew, I know we've gone quick, we've covered a lot, but I just wanted to share some of these install photos of some of our installers that just really love working with your inverter, our battery. You can see here in this picture where the brackets and how the batteries stack up on a wall as well. They're 130 pounds each to be able to stack up as well. I see that we have a portable generator question, and this is a great chance to answer that here. On the far left is a SimpliPHI 6.6 Sol-Ark 15K. And let's see, Mark's asking, can you please describe the procedure for using a 240 volt portable generator without 2-wire signal to start connected to the gen input? How would you program the inverter to accept the generator on demand without it being called for the inverter threshold? So as it would be permanently installed with generators. So I think, what I'm hearing though is, okay, so we got a Sol-Ark, we got a portable generator, and then the batteries are starting to get low. I want to take a portable generator. It has to be 240 volt. Most portables don't have a 2-wire signal to start. I'm going to start up that portable generator and start feeding the power into the Sol-Ark. Now, is what I'm about to say right, Andrew, is that as long as the 2-wire signal to start would otherwise be being sent to a standby unit, a permanently installed generator, that it would accept the portable generator power, right? So we have the gen port, and remember earlier we showed that if the batteries drop below 40%, it will accept power in the gen port from a generator, portable or not. But if the batteries were, say, 80%, they're higher than that threshold that the 2-wire signal will start would otherwise be sent. It's not going to accept power. Is that correct, or anything to add to that question?
Yeah, or I'd say if the only generator that would ever be hooked up to it would not have a 2-wire start, you could actually potentially keep the Gen Force option enabled. So that way, when that generator is plugged in and you start it up, the Sol-Ark will look to synchronize with it and accept power. If the grid's available, then we're not going to close both relays simultaneously.
Yeah. That's a good point. We can never bring
thing.
Generator in with grid. Sorry, go ahead. Keep going.
Yep. So that's one important thing to note. So grid has to be unavailable to bring in generator power to charge the batteries. You wouldn't be able to accept 2 AC sources simultaneously to kind of get multiple power sources to charge your batteries.
Yep, good point. So again, you can use the Gen Force. I didn't show that option, but there's a button to automatically start the generator as well. Mark, reach out to Andrew and I, and we're happy to get a little more context on that. Time check, we got a minute left, Andrew, so I'm going to quickly run through this, and then we'll address some more questions. You want to learn more? We're here to help. Briggs Stratton Power Academy, online learning university from Briggs Stratton. We have a lot of courses on generators and on batteries. You want to talk quickly, Andrew, on your Sol-Ark University?
Yeah, so definitely sign up for that through the Partner with Us section in our installer page of our website. Uh, our website's going through another overhaul at the moment, so things may change around, but currently it's listed under the installer section. And then someone from our team would reach out to you and actually get you a code so you can enroll.
Thank you. And what's cool is that Sol-Ark offers live learning that's NABCEP accredited, and so do we. I think that's really cool that NABCEP that we both have NABCEP. Quickly, we do have an installer program available to anybody who has not done a Briggs Stratton system. Please look us up. If you're here for NABCEP credits, email energystoragetraining@basco.com, energystoragetraining@BASCO, Briggs and Stratton Company.com for your NABCEP credits. We got sales information for Sol-Ark there, as well as us. Andrew, thank you. If anybody needs to drop off, feel free. But is there any other questions that popped up?
There was one that I was trying to type out. This one was from Andre Henderson. Can you connect AC coupling for use with a wind turbine, or if the wind turbine has 48-volt out DC output, run that directly into the batteries? So the turbine, if you're AC coupling it, it would need to be UL 1741 SA or newer certified, so that way it would respond to frequency shifting from the Sol-Ark, so to prevent overcharging of the batteries.
Yeah, we need to have a dump load.
Yeah, I've not seen that on the market yet. For if you're going to put it on the battery bus on the 48-volt output, I'd say know what you're doing.
Yeah.
You need to have a dump load or braking system with the charge controller from that turbine, so you don't overcharge the batteries.
And that's the charge controller communicating with the battery too as well. So
there are definitely a lot of systems out there in the field that are operating that way, but it's not a built-in use of the Sol-Ark, but that doesn't mean it can't be done. It's just you're kind of entering more DIY kind of territory, and proceed with caution.
Yeah, reach out to us. We'll help you walk you through it. Anything else, Andrew?
Let's see.
I see 6.6 battery outdoors. Yes, it is rated for indoor and outdoor use. Does it have New York COA? I know New York has some very strict laws, especially Manhattan. Reach out to us. I'll put you in touch with Brooke Plants, who's one of our sales business development managers for New York, and we can answer those questions as well. Email energystoragetraining@basco.com. Andre's asking, we don't have time of use electricity, but using the programming and a transfer switch and having grid charge the batteries during the day at work, and you switch to battery in the evening to reduce your electrical bill without solar. Yeah, you could do that, right, with programming?
Yes.
Okay.
Yeah,
Thank
absolutely.
you. Yeah, thank you, everyone. Thank you so much, Andrew, for joining us. And we'll see everybody next time.
All right. Thanks, Daniel. Thanks for having me.